This video will cover some basic background information about science in general, but also then discuss the scientific method. The PowerPoint that includes this information can be found on Canvas in the modules. That PowerPoint includes other sections of the notes that will be covered in other videos. So first I want to talk about what is science. So science is actually both a noun and a verb. It's a body of knowledge that scientists have built up, so it's everything we know about the natural world. But then it's also a verb in the sense that it's a way of using evidence to learn about the natural world. So you can both do science and study science. When doing science, one of the things that we most often do is collect data. And there are two main types of data that we can collect. The first is quantitative data, which is anything that can be measured numerically. So we can make these measurements using instruments such as rulers, balances, graduated cylinders, beakers, and thermometers. But whatever data you have, it's numerical. Versus qualitative data, which is more about using your senses. So the way something looks, it's green. The way it smells, the way it tastes, what it feels like, it's fuzzy. These are things that would be qualitative types of data. In science, we've already talked about the importance of observations, but what we really haven't talked about yet is what we can do with those observations. So observations often lead to inferences. So let's practice here a little bit. So object A is this thing right here. If we say that it's round and orange, is that an observation or an inference? Hopefully you said observation. But if we say object A is a basketball, that would then be an inference. All right, so now object C, that's this one over here, is round and black and white. That is an observation. Object C is larger than object B. Object B is here in the middle, of course. That would be an observation. Object B is smooth. That would be an observation. Object B is a ping pong ball. That would be an inference. Each, excuse me, each object is used in a different sport. What do you think about that one? Some of you might have said observation, some might have said inference. It can be either, depending on how you are making that statement or why you are making that statement. If you are actually observing them being used for different sports, then that's an observation. If you are inferring it because of the difference in the types of balls that they are, then that would be an inference rather than an observation. So it depends. All right, so we've already talked some about the scientific method, but I wanted to go through it again just to make sure we're all on the same page. So remember that there aren't any truly defined steps of the scientific method. Most have similar steps in common, but you'll see some lists that have 5 steps, some that have 8, some that have 12. It just depends on how those steps are broken out. So I'm gonna give you my version of the scientific method. But just as long as you have an understanding of the overall process, you're in good shape. So I like to tell a story. It is a completely made up story. I made it up many years ago. It did not actually happen, but it's a good way of just kind of showing you the scientific process without using an actual real scientific experiment. It's kind of a silly example. So most of the time, as I've said before, you're going to make some kind of observation, or a scientist makes some observation that makes them curious about something. And so they're going to identify some kind of problem or question that needs to be answered. So in my little scenario, I was out taking a walk with my dog, and I noticed on the side of the road a purple salamander. Now, salamanders are usually like brownish or greenish. They most definitely are not violent purple. But this one was violent purple. It was bright. And so I was curious as to why this salamander is purple. So that's the problem I'm going to try to solve. So I want to try and come up with a possible explanation for why this salamander is purple. And to do that, I'm probably going to do some research. I'm going to use things such as prior knowledge, logical inferences, or sometimes even imaginative guesses to try and give an explanation for why this salamander is purple. So for my little scenario here, I remember when I was a kid watching an episode of the show Diff'rent Strokes, where the older sister, who was blonde, washed her hair in a bowl of rainwater that she had collected on their balcony. And the next day, her hair was bright green. And turns out that the explanation in the show was that her hair was bright green because the rain that she collected was acid rain, and that's what caused her hair to turn green. So my thought here is, well, I remember that it rained the other day, and perhaps that rain was acidic, and maybe that's why the salamander turned purple. So my hypothesis might be something like, if salamanders are exposed to acid rain, then they will turn purple because the acidity affects their skin color, something like that. All right, so now I need to test my hypothesis, right? I need to know if I'm right. So I'm going to set up a controlled experiment. And a controlled experiment is one in which I am only going to change one variable. Everything else is going to stay the same. I'm going to have two groups, an experimental group and a control group. The experimental group is the one that's going to be exposed to this variable that I'm going to be testing. The control group will have everything else exactly the same as the experimental group, except it's not going to receive the treatment. So in my example, I'm going to have two aquariums set up for my salamanders. I'm going to have the same types of salamanders, the same number of salamanders, same type of food, same amount of light, same temperature. Every single factor that I can think of is going to be the same, except my experimental group will have acidic rain poured on them, and the control group will not. And then I'm going to collect data. In this case, I'm looking for a skin color change, so it's primarily going to be qualitative data. I'm going to be looking over a period of time, maybe a few weeks, to see if there's a color change. So the independent variable in my example would be the acid rain. That's what I'm changing as the scientist. The dependent variable is the change that I'm expecting due to my independent variable. So I'm expecting my salamander to change color. So that's what I'm going to be looking for. And as you probably heard, the bell just rang. So I'm going to sign off for the moment. I'll be back in just a second. All right, so where was I? Oh yes. All right, so I'm performing my experiment with my salamanders, and throughout the process, I am recording data, collecting anything and everything that might be relevant, but particularly focusing on any color change. I can do this in many ways. I can do it on computer, but generally the accepted method in science research is to take copious notes in paper notebooks, because that's, I don't know, somehow considered a more permanent record. And then, of course, I'm going to analyze the results of my experiment. After analyzing my data, I'm going to come to some conclusion as to whether or not my hypothesis was true. So I'm going to put all the data together and draw a conclusion. So let's say that my salamanders did not turn purple, the ones that were exposed to acid rain. So none of the salamanders in either the experimental or the control group turned purple. Then that tells me that most likely it's not the acid rain. All right, so then I would go back to the drawing board and revise my hypothesis and try and find something else. Perhaps they ate some purple berries that were along the path, and that caused them to change color. Maybe they just walked through some purple paint. I don't know. So I have to go back, revise, retest, and continue until hopefully I figure out what caused them to be purple. So let's say that the salamanders in my experimental group did turn purple, and I could then come to the conclusion that it likely was a result of the exposure to acid rain. The next step would be to publish that in a scientific journal, preferably something like Nature. As we talked about before, it needs to be something that's recognized by scientific peers as being a legit source, not People Magazine. The purpose of that is so other scientists can review the procedures, maybe repeat the experiments or tweak the experiments and see if they get the same results. And if it's continually supported by multiple experiments, then perhaps it might eventually become a theory and become known as the theory of purple salamanders. And that's really kind of it. From there, I might further research other aspects as to why the acid rain causes their skin to turn purple. So it's not the end necessarily, but just new questions that arise can be further studied.